Let's have a look at this trigonometry question. It says here, find the length of the unknown side. Well, we know this length and we know that length, so this is the length we are looking for, this side. We're given an angle, and this angle is enclosed by these two lengths, known lengths. And when we have an angle that is enclosed by two lengths, which we know what they are, we can use the law of cosines, also known as the cosine law. Let's have a look at the law of cosines for a moment. Law of cosines is used for oblique angles. An oblique angle, which means it's not a right angle triangle. And this one, we can also use the sine law, but for our case, we're going to use the cosine law. And here we have the law of cosines. The actual equations for the law of cosines, there's three of them. They're all identical to each other. Consider here we have lowercase a squared is equal to lowercase b squared plus lowercase c squared minus 2bc cosine capital A. The capital letters in this equation here represents the angle. The lowercase letters represents the length of the sides. And there are two other equations, and they're all the same. I'm going to use this one right here. And what do these variables mean? Let's have a look at a triangle. So the capital letters represents the angles. So this would be angle B. Opposite angle B would be the lowercase b, and that represents the length of that side. Here is angle C, and opposite angle C is lowercase c, which represents the length of this side. And same with A, and lowercase a was the length of the opposite side, and the same with this triangle. So let me write down the law of cosines. The one I prefer to use, c squared, is equal to a squared plus b squared minus 2ab cosine capital C. Let's look at our problem now. Here's the triangle. So which angle is A and which angle is B and which angle is C? Well, that's arbitrary. It's strictly up to you. Since I want to use this particular equation, I want this here angle to be C. So I'm going to call this angle C, capital C. Opposite angle capital C will be the length that I'm looking for, and that'll be little c, or lowercase c. These two sides then would be A or B. I can choose this one to be A or that one to be A. It really doesn't matter. I'm going to redraw this diagram over here. It would look something like this. And a really, really long line down this way. So here's 20 degrees. And I chose to call this one angle C. I'm going to arbitrarily call this angle A, and arbitrarily call this one angle B. Since this is angle A, then opposite angle A would be lowercase a. The length here was lowercase a. And this is angle B. Opposite angle B would be lowercase b, which is the length of that side. And we know what those two lengths are. So length A is 6 feet. And length B is 4 feet. So now I have a triangle that has variables that are similar to or identical to the actual equation, the law of cosine equations, which I choose to use. So I am choosing this angle to be C. I could have chosen this angle to be A or B, in which case I'd just be changing these letters, the C's and to the A's and B's, etc., according to the other equations. But as long as you know one equation, and this is the one I choose all the time, and I just simply arbitrarily choose that to be C, and I carry on. So opposite C will be the length here, lowercase c, and that's what I'm looking for, lowercase c. It says find the length of the unknown side. Having defined the law of cosines and how it's written in a triangle. Let's write it down here. I'm going to rewrite that equation down here. Lowercase c squared, that's that length, squared, is equal to a squared plus b squared, that's these two lengths, squared, minus 2 times lowercase a times lowercase b, cosine the angle C. Now here we are given units in feet. And when I do this calculation, obviously this length is going to be in feet. So I'm going to ignore the units for this calculation. Simply ignore the units for this calculation. Ignore the units. But in the end, I'm going to have to put the unit back in, and I can see that it's going to be in feet. If I put in the units here, it's just going to make it look messy. Now let's put in the numbers that we know. We want to find this length here, c. So c squared, lowercase c squared, is equal to the length a, which is given us as 6 feet, and it has to be squared, a squared, plus the length b, squared, minus 2 times ab, and we chose a to be 6, times 4, cosine of the angle between the two lengths that we know, which is 20 degrees. There's really nothing left to do here now except put those numbers into our calculator. But I'm going to do this one step at a time. C squared is equal to 6 squared is 36, plus 4 squared is 16, minus 2 times 6 times 4 is 24, cosine of 20 degrees. I'm just solving this incrementally, step by step. C squared is equal to, adding these two together, 52, minus, well, 2 times 24 is 48, cosine of 20 degrees. Now c squared then is equal to, putting this in our calculator, here we go, and that is 52 minus 48 cosine of 20 is equal to, number I get is 6 point, put all these over here somewhere. C squared then is equal to 6.894754202. But we're not finished because this is squared. So we have to take the square root of both sides in order to calculate what C is. Taking the square root of this, I have to take the square root of this one also. Therefore, C, square root of C squared is equal to C, is equal to the square root of that. I already have that number in my calculator, so it's simply a matter of putting in square root, second function, square root of that number is equal to, there's my answer, 2.625, 5786. I'll stop there. Now I also said earlier, this has to be in feet, because I left the units out. When I do all these calculations with the units, it would come to feet. But this is not the end of it. We have to change this now to proper significant figures. To proper significant figures. And the way we do that is we go back to the original question. And how many significant figures were given to us? We're assuming this was a measurement. Somebody took a measurement here and calculated 4 feet, 4.0 feet, and made a measurement here and said this was 6.0 feet. So that's 2 significant figures. This is 2 significant figures. The angle between them is also 2 significant figures. Therefore, the final answer cannot be any greater than the least significant figure in our word problem. In this case, it's just 2. So we have to round this to 2 significant figures. Round to 2 sig figs. And we just simply use less than 5 round down, greater than 5 round up. So here's our two digits, 1, 2. This is less than 5, so we simply round down. Therefore, the length C is equal to 2.6 feet.